The Sun is a high-temperature object that emits powerful light with high energy, warming the Earth. This warmth is essential to our lives. But because of this heat, the Earth also emits light with much lower energy, known as infrared light. This invisible light plays a crucial role in global warming. When the carbon dioxide, CO2 molecule is released into the atmosphere, it interacts with infrared light wave emitted from the Earth. Especially, a light wave has electrical characteristics, and at this point, the wave has both positive and negative electric components. Now, in carbon dioxide, one carbon atom is chemically bonded with two oxygen atoms. However, when different atoms are combined, electron distribution of each atom changes based on the chemical property known as electronegativity. As a result, in the case of CO2, the carbon atom is positively charged while the oxygen atoms carry negative charges. Because of this difference, wave's negative component generates an upward force on the positively charged carbon and a downward force on the negatively charged oxygen. When the wave propagates, then each atom experiences a force in the opposite direction. Moreover, the chemical bonds of a molecule can be considered as flexible springs, and by the advance of the alternating infrared wave, the carbon and oxygen atoms start vibrating and light disappears. In other words, light is absorbed by carbon dioxide, and the energy of the light is converted into the vibrational energy of the molecule. However, this excited state is unstable, and the CO2 stops vibrating after a brief period. At this moment, infrared light is emitted from CO2, and therefore, infrared light is reflected back toward the Earth. To be precise, half of the emitted light is directed toward the Earth, while the other half radiates into outer space. On the other hand, we know that the atmosphere contains many oxygen and nitrogen molecules, but these molecules are composed of identical atoms, and therefore the electronegativity is exactly the same. So these atoms maintain charge neutrality. As a result, infrared light simply passes through these molecules without any interaction. Within the atmosphere, CO2 is mixed with oxygen and nitrogen, yet only the light absorbed by carbon dioxide is reflected back toward the Earth. Methane, CH4, also interacts with infrared light. The carbon atom has higher electronegativity than hydrogen, and the charge distribution becomes like this. So when CH4 is exposed to advancing infrared light, CH4 molecule vibrates and absorbs the light, which is then emitted from the methane molecule. The whole procedure is exactly the same as that of carbon dioxide. Other gases, such as nitrous oxide, N2O, and chlorofluorocarbon, CF2Cl2, also absorb and emit light because these molecules consist of different atoms with different electronegativity. So carbon dioxide, methane, nitrous oxide, and chlorofluorocarbon, all these gases absorb infrared light strongly, and the absorbed light is reflected back toward the Earth. Importantly, these additional energy reflections heat up the Earth, and this phenomenon is known as greenhouse effect, and these gases are called specifically greenhouse gases. We need to know that greenhouse effect is a purely electronic process we cannot control, and when these gases are released into the atmosphere, Earth's temperature increases. Always.